Okay, my students are working on finding surface area of three-dimensional shapes. And we have this shape here, and I thought it'd be a good one for me to demonstrate with my students. It seems like they got a pretty good handle on finding surface area of rectangular prisms and cubes, but this shape here, it's a little bit different. And they also, I found out today, they forgot how to find the area of a triangle, and we had to review that a little bit, so I feel like this would be a good one for me to step in and demonstrate for them in class today. Now this is a triangular prism. It's a triangular prism, and I've got students in the class, and I'm looking at all of my students, and I hope that they're actively listening, that they're looking at the Promethean board, that they're sitting up, that they're paying close attention. And children, if you have any questions as I go through this process, if I need to clarify something, stop me, and I'll clarify it for you. So please pay close attention. Okay. So the first thing I like to do with these types of shapes, when you have three-dimensional shapes, is I like to convert them into nets. Now we just got finished looking at three-dimensional shapes and nets, and so I don't think this ought to be too hard. So I'm going to go ahead and convert this shape to some nets. So the first thing I'm going to do is I'll always start out with my base. I start out with my base, and then I go from there. So I'm going to do that part here. So I know this is a triangular prism. I know it's going to have a rectangle for the base, because that's how prisms are. They'll have like a rectangular or square base perhaps, or they could have, you know, any kind of other shape. They could have, like, for instance, a pentagon for a base. They could have all kinds of shapes. But anyhow, well, I guess it just depends on what side or what face the shape is laying on. But I'm going to go ahead and put a rectangle for the base of this shape. So here's my rectangle, and I know that the rectangle is going to be 7. It's going to be 7 by 12, because this edge will be 7 meters. And this part here will be 12 meters. And I also noticed that this part of the shape is going to be 7 meters by 12 meters, because this edge is 7 meters, this edge is 12. And then this side here is 7 meters, and I know it's also going to be 12 meters. So I need 3 of those shapes. So I'm going to go ahead and make 3 of those shapes just like this. Okay. Alright, so I'm going to go ahead now and pull these shapes here. So here is my base, and here will be this side, and then here will be this side. So now I need to have this triangular front, which would be here, and then the other triangular part that would be here. So I'm going to go ahead and make those triangular parts. Now this triangular part, for it to be touching, it would be upside down, but it's pretty hard for me to get these to flip. I'll try to flip one of these in a second, but first let me go ahead and copy this one, because it's going to have the same dimensions, the back wheel, as this one. Okay, so I'm going to put this one here. Ooh, it's a little bit long. Let's see if I can. Okay, maybe I can just leave it like that and say it's not drawn to scale. So I'll leave it like that, and it's not drawn to scale, everybody. Okay, this one, I don't know if it'll let me flip. Yes, it will not let me flip it. So I'm not even going to try to use this one. I'm just going to draw. I'll just try to sketch one out here. So here, let me get red for it. Well, that's not red, it's black, but it doesn't matter. So this here would be the face. Now the reason I do the nets is because I don't want to leave any sides out. If I find the surface area of this whole shape, but I forget about the triangle in the back, if I forget about this one, leave it off, then my answer is going to be wrong. So I always do the net just to make sure every part is there. You got it? Okay, now let's go ahead and plug in some dimensions. So let's see. I already said that this was 7 by 12, so I'm going to go ahead and put that 7 meters by 12. This is 7 meters by 12. That's not looking good. And this is 7 meters by 12. And when I look at this triangle, the base is 7 meters, so I'll say 7 meters here, and the height is 6. The height is 6. Now when it comes to triangles, we don't worry about the side length. We only worry about the height and the base, because our formula, and we'll talk about that in a minute, only requires the height and the base. And so this one here is also going to have 6 as the height and 7 as the base. Now it asks for part A is the triangle that forms the base of the prism equilateral, isosceles, or scaling. Well, because it's 7 by 7 by 7, I'm going to say that's equilateral. All the sides are the same. Now, if only 2 sides were the same, it would be isosceles. If all 3 sides were different, it would be scalene. But because all the sides are the same, I'm going to put equilateral. Now, I'm going to just write equilateral. If I were a 6th grade student, and this were part of my assignment that I had to do for class, I would probably phrase it as a sentence. I would include the stem. I would say that the triangle that forms the base of the prism is equilateral. That's what I would have said. But to save time and move on, because we're getting close to lunch, I'm going to move on. B, write a numeric expression to represent the surface area of the figure. Okay, I'm going to have to put B down here. I just need to have space to write this. So I have 3 rectangles, and the formula for finding the area of a rectangle is area equals base times height. Area equals base times height. Now, since we have 3 that are exactly the same, and the base would be, we'll say 7, the height 12, I'm going to say area equals 3 times 7 times 12. And I'm going to add that, and since we have 2 triangles that are congruent, and the area formula for finding the area of a triangle is half times base times height, I could say that half, I'm going to say 2 times 1/2 times the base, we'd say is 6, times the height, 7, the height is 6, and leave it like that. So this could be a numeric expression to represent the surface area of the figure. Now, students, how many of you have what I have so far? Okay, I'm seeing quite a few hands up, so very good, very good. I'm impressed so far. Now, C says, what's the surface area of the figure? Well, let's go ahead and figure that out. 7 times 12 is going to be 84. True or false, boys and girls? Yeah, that's true. 7 times 12 is 84. And 3 times 84, well, 3 times 80 is 240. And 3 times 4 is 12. So that's going to be 252. You agree with that, boys and girls?
Yes.
Plus, well, let's do this one this way. Half of 6 is 3. 3 times 7 is 21, and I can do that any way I want to because of the commutative property of multiplication. I can say half times 6 first. So half times 6 is 3. 3 times 7 is 21. 2 times 21 is 42. You got that?
Yeah.
So now I just have to add those together. And so that's going to give me 294, and the unit measure is meters squared. So this, I would say, the surface area of the figure is 294 meters squared. And D, how did the number of congruent faces on the figure help you write your number sentence? Well, when I look at my number sentence here, and maybe I should go ahead and write like this to complete my number sentence, I could say that, well, because I had 3 faces that were congruent, I just had to say 3 times 7 times 12. Because I had 2 faces that were congruent, I could say 2 times, half times 7 times 6. It really helped me that way. Now, I could have written that out. I could have said 7 times 12 plus 7 times 12 plus 7 times 12 plus 1/2 times 7 times 6 plus 1/2 times 7 times 6 and get my answer, but that would be a very long number sentence. And a long time ago, remember, boys and girls, a long time ago we combined like terms. We did things like that. I don't know if this is exactly like you would say combining like terms, but because they are congruent, you know, it is kind of simplifying it quite a bit when you write it like that. All right. Now, Does anybody have any questions about the process, or is my answer different from what you came up with? How many of you got the same answer I did? Okay, did anybody do this a different way? You all did it exactly the same way as I did?
No.
Okay, well you all must be geniuses.